Hi guys, for today's lesson we're going to be dealing with language and notation of angles. What I mean by the language is a lot of these sorts of words that you're going to have to remember: adjacent, complementary, supplementary, and what they mean. And also the notation of angles is some of these symbols that we're going to be dealing with, like that symbol there and this symbol here and some of the other things. So it's really important that you're able to deal with the language of angles. Okay, so first up, adjacent angles. So they are two angles that share a line and a vertex. They have to share both. So for example, we can see here, we've got two adjacent angles, this angle here and this angle here, because they both share this line, and the point at both of these angles is this dot right here. They share the same vertex. Their point is at the same position. So we call angle ACB and angle BCD, we call these angles adjacent angles. Notice that when we are naming these sorts of angles, like this red one here that I've wrapped around, you need to make sure that the letter in the middle is your C, is the letter at the vertex. So it's really important that we had our C in the middle, because the C is at our vertex for both of these angles. And then the other angles around the C are going to be your angles at the points on the end of your angle, if that makes sense. Okay, so next up, complementary angles. So they are two adjacent angles that add up to 90. So we need our angles to be adjacent, and we need them also to add up to 90 degrees. So for example, look at these two angles. So this angle and this angle definitely definitely adjacent. They share that line and they share the same vertex, and they also add up to 90 degrees, as you can see by this right angle symbol here. So we would say that X and Y are complementary. They add up to 90 degrees. Supplementary angles are a very similar concept, but instead of 90 degrees, they add up to 180 degrees. So as you can see here, angle ABC and CBD are supplementary, because if I wrap around these two, you notice that they share this line. They share the same vertex, this point here. And because there's 180 degrees in a straight line, so therefore this is going to be supplementary to that, because they both lie on top of this straight line, which is 180 degrees. Okay, angles in a revolution. So a revolution is another word for like a full circle. Like going around in a full circle is what we call a revolution. So two or more angles that share the same vertex, which add to 360. So for example, X, Y, and Z add to 360, because you'll notice that all three of these angles, they each share this vertex, this middle point here. And if I add this angle to this angle to this angle, they make a full revolution. They add up to 360 degrees. Next up is vertically opposite angles. So they are two pairs of equal angles formed when two straight lines cross each other. So when we make a cross, that's the idea. So having a look here, we've got two straight lines here, and they're making this cross. When that happens, we get two pairs of vertically opposite angles. So this angle A and B, this angle A and this angle B, we say that they're a pair. They are going to be equal to each other, because they're kind of like on the opposite angles. They're like on opposite sides of this cross here. And the same thing goes for this angle and this angle, C and D. They're like directly opposite each other from this cross. These angles are going to be the same size. Okay, next up, perpendicular lines, not angles. So perpendicular lines are two lines that cross at 90 degrees. For example, look at this diagram here. You can see that these two lines, they make this 90 degree angle in the middle. So we'd say that the line XY, that line's called XY, is perpendicular to AB. And this is how we can write that nice and quickly. XY is perpendicular to AB. The symbol for perpendicular is this upside down T. So that means XY is perpendicular to AB. Okay, so some rules to remember. So when finding the value of unknown angles without a protractor, So in the past, we've found angles by measuring them with a protractor. But if you don't have one of those, you need to show reasoning for your answer. And the reasoning is by using some of these sorts of relationships. For example, we could be using that, these are the sorts of words you need to be dealing with. Okay, so find the value of x, showing reasoning. So we want to try and figure out what this angle is, how big this angle is. And I'll tell you that that's a 90-degree angle there, and I'll tell you that that's 140 degrees. That will be enough information to figure out what x is using these things. But how do we do it? So first up, I'll say to you that, well, if I know that that's 140, I can figure out what that angle is right there. So I'm going to write that angle DFE, that angle there, is equal to 180. Take away this 140 angle. And the reason is because they're supplementary angles. If I look at this angle and this angle, they add up to 180 because they lie beneath that straight line. So therefore, they add up to 180 together. I can go 180, take away that 140, and I get that this angle here is 40 degrees. And I might write that in right now. I'll put a 40-degree angle there. Next up, we've got angle AFB. So I noticed that angle there is 40. That means that angle up there would be 40 as well. And the reason is because if I make a cross with those two lines there, these two lines are straight opposite each other. They're vertically opposite. And vertically opposite angles are equal. So therefore, if that's 40, that must be 40. So I'm going to write that angle AFB, this angle up here that one there is equal to 40. And the reason is because we have vertically opposite angles here. Okay, and lastly, I'm going to say that x is equal to 360. Take away 140, this angle here. Take away 40, this one here. Sorry, I'll write that that's a 40-degree angle as well. Take away 40 again, so taking away that one as well. And taking away 90, take away that one. And the reason is because all of these angles that I'm pretty much looking at are going to be, all these angles around are going to add up to 360 degrees because they make a full revolution around this point right here. So therefore, I can do 360 and take away all the ones that I've got. And that will leave me over with my size of x. So that comes out as, when I put all that into my calculator, x comes out as 50 degrees. And the reason for that is because all these angles make a revolution. So these sorts of reasonings are really important to show. It's important that you're showing why you're getting this certain value of x, so this 50-degree angle. Okay, so I hope this helps with the questions. Good luck.